This is going to be the first video on rational functions. Rational functions are those functions that can be expressed as a ratio or a fraction. Here we have f of x is equal to p of x divided by q of x. P of x represents the function that's going to be in your numerator, and then q of x represents the function that's going to be in your denominator. So we're dividing one function by the other. Remember that we can't divide by 0, so q of x cannot be equal to 0. So we have some parts that we want to consider when we're graphing and looking at rational functions. The parts we want to consider are, we want to find the zeros of the polynomial. And then we want to find the zeros of the denominator, and that's going to determine any vertical asymptotes that we may have. Then we also want to look at the end behavior of the function to find any horizontal asymptotes. Then we want to find any y-intercepts, and that's going to give us enough points here we can possibly graph the function. We can also find some other helpful values as well, if there are any that will help us determine what this function is going to look like. As always, you can graph it on your graphing calculator after the fact, but being able to find these certain points is going to give us some algebra skills that are going to be important later on. Let's take a look at a rational function. Let's say we have f of x is equal to 1 over x minus 1. Let's go ahead and find all of these values that we have here. For part 1, where we want to find the zeros, we want to set our numerator equal to 0. And we take our numerator equal to 0, that will tell us if there are any zeros in our polynomial. Our numerator here is equal to 1, which is not equal to 0. So therefore there are no roots or zeros. This means that this function will never cross the x-axis. Now we want to look at any zeros in the denominator. And here I'm going to get x minus 1 is equal to 0, or x is equal to 1. This gives us something called our vertical asymptote. An asymptote is an imaginary line that is vertical on your graph where a function is going to approach but not cross it. And it's either going to go to positive infinity or it's going to go to negative infinity. The next part we want to look at to see if there are any horizontal asymptotes. And this is what happens when it goes to negative infinity and positive infinity. And I'll discuss more about this later on. But if we put in a really large positive number, let's say we put 1,000 in here, we're going to basically have 1 divided by 1,000. That's pretty close to 0. Or 1 divided by 1,000,000 as we go to more towards positive infinity. That's going to be really close to 0. So as f of x, as x goes to 0, f of x is going to go to, as x goes to infinity, f of x is going to be going to 0. Now let's look what happens when we put in large negative numbers. Let's put in negative 1,000. Well, we have 1 divided by negative 1,000, which is approaching 0 as well. So as x approaches negative infinity, f of x is going to go to 0. We'll talk a little bit more about the specifics of end behavior right now, but for this simple example, we have a picture of what's going to be happening towards the end. Finally, we want to find our y-intercept, where we have f of 0 is equal to 1 over 0 minus 1. That's equal to minus 1. So I have this is going to be my y-intercept. So now as I graph my function, I have my vertical asymptote at 1. I have a y-intercept at -1. I know that goes towards 0 from -infinity. So it's going to be something like this. Across here, excuse me. So that's, and then on the positive side, it's going to look something like this. And I'll do another video example in my next video.